Okay, in this example, we are going to talk about something on something called translation vectors. So what exactly is translation vector? It's more like a movement vectors. So this translation vector will tell you how to move from one point to another point. We can also do it like an addition of vectors, or you can visualize it. Okay, so for example, here, I'm going to show you a visual idea first. Okay, so I'm going to show the visual idea in terms of the coordinates. Okay, try my best to draw properly. So I'm going to start off with this coordinate. So this coordinate is somewhere like this. Okay, so this is the point D. So point D is translated. Translated is like it's being moved by this vector to the point E. So what do we mean by this? Okay, so if you understood DE, that means, right, okay, what is your understanding of DE? DE means that you are going to start from D and then you're going to end at E. And you're going to end at E by moving 3 units to the right. Okay, we talk about the meaning of the numbers in the front part of vectors. And then I'm going to do a 4 units up. Correct. So visually, it's going to be something like this. So I'm going to do like 3 units here. And then after that, I'm going to do like 4 units up. So I will get E. So that is the translation vector. So it is telling you to move 3 units to the right and then 4 units up. If you go a bit of calculation, so if this one is 3 units, this part will be a -2. And then if this is 7, and then this part is 4 units, this will be 11. So actually, if you do out a rough sketch, you can tell that E is -2, 7. If you visualize it from the movement, a bit of a rough idea, you will come to this answer. Okay, so how are we going to do this? So how are we going to do this? If I'm not going to be drawing out. So if I'm not going to be drawing out, I'm going to see the coordinate as the position vector. So D is -5, 7. I will see it as OD equal to -5, 7. Okay, so that will be OD is -5, 7. Okay, and I'm also given a DE. So if I use a concept of position vector, that means this is like a OE. So if I do it like a position vector, the position vector, so that means it's like fill in the blank one more time. So you fill in the blank one more time. And you find that you can fill in the blank with D, and you actually got your OD and your DE. So it actually get you the same answer as with the sketch. Sorry, this part I wrote wrongly. 7 plus 4 is 11. So can you see? If I do it by the sketch, I will have gotten -2, 11. But if I do it by the addition of vector, position vector idea, I also got the same answer. Okay, so it's the same thing. You can think about it in the drawing idea. So, or you can think about it in the addition of vectors idea. So let's try question B. So if you are going to try question B, we got a coordinate which I can change to a position vector. And then I also, now my FG is a blank. So you realize my FG is the blank. But I do have a OG. So I do have a OG, which is like 6 minus 2. So in a way, I want to find out how do you move from F to G. So because FG means how do you move from F, starting from F going to G. So if you want to draw, you can draw. I'm quite sure if you draw it out, you count the number of units, you can get the answer. But of course, we're going to be using the fill in the blank idea. So in fact, right, you can do a fill in the blank with this. So if you fill in the blank, it will be FO plus OG. And of course, you got to reverse to get the position vector. So you will get a minus 0, 10 plus 6 minus 2. So you'll be able to get this. And the answer is 6 minus 12. So you can do it like normal adding, or you can do it visualizing it as how the movement. Okay, so actually this one, some students, they may do it another way. Some students, right, if they can see it, they actually will do it this way. So for example, some students will be like, oh, OF plus FG. Because these two are the same already, it will actually give you OG. So some people can think of it this way. Okay, they can think of it this way, and then they do something like this. And they will still get the same answer if there's no sign error. So some people will do it like this, and you still get the same answer. Okay, so it's your choice. Whatever is it, I'm still going for the addition, the fill in the blank idea. So you can fill in the blank in this way, or you can fill in the blank in this way. It doesn't matter. If you got no careless mistake, whichever way that you do by, you will get the correct answer. So that is what we call by translation vector. It's a movement vector that tells you how to move from a point to another point.